FEA cater to. So today I'm going to talk about different items, and this is the agenda of my webinar today. I hope you can see the agenda screen on your computers. So I'm going to talk about the application areas of Midas FEA, where you can apply Midas FEA, what are the application areas or components of the bridges where you can use Midas FEA. The key features of Midas FEA, being a finite element analysis software, what are the key features that it provides to the users for easy and quick analysis of bridges. Then I'm going to talk about the application area of Midas FEA specific to pre-stressed concrete bridges, steel bridges, and the special analysis that it provides. And then we're going to talk about the integration of Midas FEA with Midas Civil. So as I mentioned in the beginning, you can still use Midas Civil as your mainstream finite element analysis software, but for certain specific cases, Midas FEA can be complementary to Midas Civil. Now let me talk about the application areas of Midas FEA. First of all, you can use Midas FEA for any non-regular bridges. If you are working with a straight bridge which has got little skew, which has simple curvature, which is a regular bridge, which is a typical bridge, you can easily use Midas Civil for performing different types of analysis on it. But when it comes to bridges which have a higher curvature, which have the horizontal as well as the vertical curvature in them, we require 3D finite element analysis so that we can capture the torsional bending of the bridge, the warping stresses which are generated due to the curvature, and how the load is distributed through the connecting elements. So as an example here, I have shown a bridge which has a large curvature here, and the deformed shape is shown, and you can see how the cross section distorts due to warping. So if you are working with Midas Civil, you will model this particular bridge as a grillage type, and you will not be able to obtain the distortion in the cross section, but Midas FEA will help you to obtain the distortion in the cross section. Again, when you are working with pre-stressed concrete bridges, sometimes you must have the projects in which the deck width is changing with the length of the bridge, or the bridge is bifurcating into two branches after a certain length. So for this type of project specifically, Midas FEA can be used to model everything in 3D, and here you can capture the effect of changing depth or width of the deck. You can take into account the tendon which is spanning from one end of the bridge to the another end of the bridge. If you have bifurcation in the webs, a tendon might go from one web to another web due to the bifurcation zone. And here in Midas FEA, you can study all these effects so that you can be a bit more confident about your design. So here you can see in this particular example here, I have shown a bridge which is bifurcating into two different bridges after a certain length. And here you can see the stress at various cross sections. You can also see that the deck width is changing with the distance. And here I have shown you the cross sections at different intervals and the stresses in the cross section. So basically for these projects, the first one that I've shown you was a curved bridge, and here it's a bridge which has got bifurcating branches. You can use Midas FEA for these type of projects. Talking about the bridge connection elements, if you want to design or analyze bridge connection elements, Midas FEA can be of good use to you. So here you can see that in this particular truss bridge, I have modeled the connection element in Midas FEA, and I have performed stress analysis as well as fatigue analysis on it so that I can easily design it. So here Midas FEA can be used for any type of bridge connection system analysis. You can obtain the stress at each region of connection. You can study the stress change. You can perform fatigue analysis, and specifically for these type of connection elements, we sometimes need material nonlinear analysis, and Midas FEA can help you with that too. Now talking about some special analysis, some bridge types require specific analysis, such as if you want to study the aerodynamic behavior of a bridge, then you can perform CFD, computational fluid dynamic analysis in Midas FEA, and you can also perform interface nonlinear analysis. So as you can see as an example here in this particular bridge type here, you can see the three layers. One, we have a steel layer, we have a concrete layer in a particular cross section. So we have defined the interface properties between the steel and the concrete, and we have performed the interface nonlinear analysis. So again, if you want to be more sure about the design that you are doing, you can use Midas FEA. You can use the features of Midas FEA to perform the 3D finite element analysis so that you can be more sure about what you are doing. Again, Midas FEA can help you with cracking analysis and context analysis. So right now you must have seen how Midas FEA is a bit different from Midas Civil, and basically you would have realized that you can use both the products complementary to each other. Now let us talk about some of the key features of Midas FEA. Being a finite element analysis software, it has all the components that a finite element analysis software generally has. So here you can see that it has a geometric modeler, it has a mesh generator, it has a preprocessor which can be used to define the construction stages or loading on the project. Then you can use the solver to perform the analysis, and there is a post processor which can give you the results. And finally, you can also use the report generator feature which Midas FEA has to create the reports for your projects. Okay, now let us be more specific about these key features of Midas FEA, and let me show you some of the modeling features of Midas FEA. On your screen here is our simple features, modeling features of Midas FEA that will help you in day-to-day projects that you are working with in Midas FEA. So just to show you these modeling features, let me take you to Midas FEA itself and let me show you the modeling of different type of bridges in Midas FEA. Okay, so I have opened Midas FEA in front of you guys, and here you can see that on the top we have the menu bar. On the left hand side we have the work tree as we have in Midas 10 or Midas Civil, and here it is the model window. So here let's say we want to model this kind of a bridge in Midas Civil, and here let me show you the top view of this particular bridge. So it has a PSC cross section. It has a multi-cell cross section as you can see here, and the bridge divides into two separate bridges after a certain length. So after 80 feet from starting, it bifurcates into two segments. And let us see how we can model this particular type of bridge in Midas FEA by using the geometric modeling features of Midas FEA. So I'll begin with the start model here. Let me show you how the start model looks like for this particular project. Okay, here it is on your screens now. So here you can see that I have created the cross section at two different lengths here. Let me show you the top view. You can see this is the first cross section. You can see that the deck width is varied along the length of the bridge, and then I have created the guide curves for the two branches which are offsetting from the main bridge. So let us see how we can create the solids that are required for creating this geometry of the bridge. So I'll go to the modeling features. So I'm going to go to geometry, generator feature, and here we have this loft feature which can be used to create the solid between two profiles. So here you can see that I selected the duct of one cross section and another cross section at a different distance, and once I click on apply, the solid is created. Similarly, I'm going to create the solids for other webs. Here you can see that the two ducts which are in the interior, the width of the ducts changes, and here it looks like. So here you can see that the lofting has been done for the webs. Now I'm going to do the lofting for the exterior cross section. So here I'm selecting the cross sections. Okay, and once I do the lofting, you can see that the solid has been created. Now let me increase the transparency for you guys so that you can easily see how the solids look like. So here it is. At this point of time, you would realize that right now it's just a solid slab and we have no ducts inside this particular slab. So for creating the ducts, we have the Boolean operation for you. All of us are very familiar with Boolean operation, cut add, etc. So I'm going to use the cut Boolean operation, and I'm going to cut the webs that I created, the solids for the web that I created from the main cross section. So once I do this, you can see that now the slab has got ducts in it, and this is how we can easily model the bridge which has the varying deck width along the length. So as you can see here, this is how it has been modeled. Now let us go ahead and model the branches of this bridge. For modeling the branches, I'm gonna use the sweep feature. So with the help of sweep feature, you can easily tell the program that this particular cross section has to be swept along a particular guide curve, which is the center line of the bridge. And once I click on apply, you will see that the exterior solid has been created. Similarly, I'm gonna create the duct inside this solid. So here I'm gonna select the guide curve again. So the solid has been created, and again I'm gonna use the Boolean operation cut so that I can cut the duct from the outer solid. Here you go. So here you can see that one branch of the bridge has been modeled. Now let us complete the modeling, and let us now model the second branch, and let us complete the solid, the diaphragm, which is connecting these two branches with the. So here we go. Let's again use the loft feature. Let's use the wires for the cross section to loft it. So let me zoom in at this location. Okay. So the loft, this thing has been created. Now let us create the second branch of the bridge. Again, we're going to use the sweep feature. So I'm creating the solid for the duct, and now I'm creating the exterior solid, the guide curve, which be the center line of the bridge, and here we go. Let me increase the transparency. This is how it looks like. And here we have completed the modeling of this particular bridge. So basically it's pretty simple to model these kind of solids in Midas FEA, and here you can easily use these simple geometric modeling features so that you can complete the modeling of the bridge in no time. Now let us see how the tendons have been modeled in this particular bridge. So I have already created the tendon modeling here. Let me show you how it looks like, and this is how it looks like. Let me show you the top view. So you can see that these tendons are spanning from the outer web of the multi-cell box girder to the first branch, and this is how it has been created. So basically Midas FEA provides you with simple modeling features that can be used to model these irregular bridge shapes very easily. Now let us go ahead and talk about the meshing features in Midas FEA. Midas FEA allow you to mesh any kind of solid or surface very easily. We have meshers which are available in Midas FEA which can easily mesh different items for you, and all you gotta do is select the solid, specify what element size do you want, and Midas FEA will automatically take into account where the two solids interact. And these two things combined, the geometric modeling features combined with the mesh generation with the FEM solver, can be used to perform these many type of analysis. So here you can see you can perform static analysis, construction stage analysis, moving load analysis, and other special analysis. I'm going to talk about these type of analysis once we go through specific bridge types in Midas FEA. So now let us talk about pre-stressed concrete bridges specifically in Midas FEA. So as I've already shown you, Midas FEA can be used to perform pre-stressed concrete bridge analysis which has a curve or which has a bifurcation in the webs or which has the deck width changing with the length of the bridge, and Midas FEA will let you define the 3D tendons very easily. The connection of the tendons with the or the reinforcement with the solids is done automatically by Midas FEA, so you don't have to worry about matching the node of the solid along with the tendons. Midas FEA will do it automatically for you, and you can also analyze the transverse tendons along with the longitudinal tendons in Midas FEA. So again, it is a bit different from Midas Civil here. In Midas Civil, you model the longitudinal tendons only in the cross section, but here in Midas FEA, you can model the longitudinal tendons as well as the transverse tendons so that you can study the real behavior of the bridge. Again, here I've shown you some examples of how the tendon layout has been done. Now, for modeling the 3D tendons in Midas FEA, we have provided the interface which is exactly similar to Midas Civil interface. And since you guys are very much familiar with how to deal with tendon definition in Midas Civil, you can easily use this particular dialog box to define the tendons in 3D. So you can select the type of curve that you want to define, then you can punch in the tendon coordinates, and this is how you can easily define the tendons in Midas FEA. Now let us talk about the pre-stressed concrete bridges which have varying number of webs or the web depth changes. So here you can see in this particular bridge example that I've taken here, the web bifurcates at two different positions along the length of the bridge, and it bifurcates at the exterior webs. So let us see how you can model this type of bridge easily in Midas FEA. So let me take you to Midas FEA one more time, and quickly let me show you how you can model this kind of bridge in Midas FEA. Okay, so I have opened Midas FEA in front of you guys again, and here you can see that to model this particular bridge, I have already created the layout of the webs. So I have created the guide curves that I would be using for creating the webs, and now let me show you how you can use these curves to model the bifurcating webs easily. So I'm going to go to geometry, generator feature, sweep again, and I'm going to sweep the webs along with the guide curves so that we can model the individual webs at several locations. Here we go. So right now we are creating individual webs. So basically to create the whole cross section, I'm using a three-step process. I'm gonna first create the webs. I'm gonna create the bifurcations in the web. Then I'm gonna create the top slab and the bottom slab, and then I'm gonna fuse all the solids into one solid. So let me first create these webs here. Okay, moving ahead. Okay, let me show you the top view now. This is how it looks like. So here you can see that now we have different webs, and these webs bifurcate at different locations. Now since the web on the two exterior sides, they are representing the same solid, so I'm going to use the Boolean operation fuse, and I'm going to fuse the bifurcations that I created individually, the bifurcation solids, so that I can make only one solid out of three different web portions that I've created. Okay, so this is how it is done. Similarly for the web at other location. And we are done with it. So here now you can see after I used the fusion technique, you can see that now we have only one solid which is representing the bifurcated webs. Now let us go ahead and define the top deck and the bottom deck. So here I'm going to go to generator feature extrude, and I'm going to extrude this surface that I've already created in the Z direction. This is how it will be done. You can see before it is actually done. And now I'm going to create the lower slab. I'm going to select the direction. and here it is. So right now you can see that in this particular bridge that we are modeling, we have three different solids representing the total cross section. We have the top deck, we have the individual webs, and then we have the lower slab. So now let me fuse them all of them into only a single solid. So I'm going to show all solids, and here I'm going to again use the Boolean operation fuse. I'm going to select the top slab, and I'm going to select all the other solids so that they can be fused together. And once I select it like this, I'm going to hit on OK, and you will see that the solids have been fused. So this is how you can create the models easily with Midas FEA. I've shown you the technique by which you can easily create these kind of models. And here you can see that now everything is under one solid only. Now you can mesh it, you can perform analysis, you can define the tendons and whatnot so that you can proceed to design it. Okay, let's go ahead and talk about bridge intersections for a while. So as I've already shown you, you can model bridge intersections easily with Midas FEA, and here it looks like. Now at this point of time, let us see some of the post-processing results from Midas FEA. So let me open Midas FEA one more time in front of you guys, and let me show you some of the results that you can obtain from Midas FEA. Okay, here we go. So on your screen now is Midas FEA, in which okay, I think I opened a wrong model here. Let me quickly open another model in front of you. Okay, if you guys have any question, you can post the questions at any point of time, and towards the end of the session we are going to take the queries from you guys. So whatever questions that are coming to your mind, you can ask, you can type in the question, and towards the end of the session we are going to take all the questions at the same time. Okay, here we go. So I have opened this model in front of you, and let us see the results that you can obtain from Midas FEA. So let us see the displacements. This is how the displacements look like. If you want to obtain the displacements at any cross section, you can easily get that. We have several options for that. Let me show you some of the options here. So we have the clipping plane here. In the clipping plane, you can move it around and you can see what is the deformation inside the bridge structure, like this. So basically you can create the clipping plane at any location. And you can easily obtain the stresses or deformation at this location. So now let us see the stresses at this particular location. So I'm going to go to stresses. Let me just uncheck all these tendons here. So I'm going to hide all these tendons and these ones too. Okay. So you can see the stresses, how the stresses are developed in the cross section. You can see that you can cut the section into half, and you can easily see how the stresses are developed in the cross sections. And similarly, you can obtain, since this particular project contains the tendons, you can also obtain the results in the tendon. So let me show you how the results in the tendon can be obtained. So here I'm going to go to 1D reinforcement tendons, and let us see the stresses in the tendons. So basically, if you want to see the stresses in the tendon, you got to go to 1D reinforcement stresses, and you can obtain the stresses in the tendons. Now, some of you must be wondering on how we can obtain the results for a particular cross section in Midas FEA. So as you must have noticed in Midas Civil that we have a local direction for some feature that allow you to obtain the results that you want for the designing of the cross section, like a design bending moment, shear force, etc. So we have a similar feature here. So the local direction force sum, with the help of this particular feature, you can create a cross section, and on that particular cross section then you can obtain the results for the designing of the cross section. So basically, let me show you the tabular results. So basically here I created a cross section and I want to obtain what are the bending moments and the shear forces at that cross section, and this is how it looks like. So here you can see the shear force and the bending moment. Let me change the units for you. Okay. So basically it's not only about analyzing the 3D finite elements, but if you want to obtain the results that we generally require so that we can perform the code checks, you can obtain that from Midas FEA. Okay, let us move ahead, and now let's talk about concrete nonlinear analysis. So basically in Midas FEA we have different plastic materials that you can associate with the concrete material model, and you can perform cracking analysis. You can define the reinforcements. As you can see in this particular example, I have defined the reinforcement, and you can easily estimate how the cracking of the concrete will happen. Sometimes when we work on very specific projects, we need to know what would be the behavior of a particular cross section, how it is going to crack. If it is a connection, how is it going to behave under certain stresses. Then you can use these type of nonlinear models, the cracking models, and you can obtain the crack pattern in a particular location. Now let us talk about steel bridges, how Midas FEA can help you to model steel bridges efficiently. So talking about the modeling of steel bridges, here you can see that it is very easy to model the finite elements, the shell models, the shell plate elements, etc. easily for steel bridges. You can see that I have modeled the shell for the deck concrete as well as the shell for the steel webs here, and I've also modeled the cross frames in this particular model. And it is pretty easy and convenient to do it with Midas FEA. So let me take you to Midas FEA itself and let us see some of the modeling features that we have for steel bridges. Okay, here we go. So as you can see here, I have created the cross section of the bridge and I have created the layout of the bridge. It's a reverse S-curve bridge, and let us see how Midas FEA can help you in modeling this type of bridge. So for modeling the steel bridges, we have a special feature known as sweep translate feature in Midas FEA. And all you're going to do is select the cross section that you have created at one location. And once you select the cross section like this, you can select the guide curve. So the guide curve is selected. Then you can specify what are the divisions that you require, and then you can ask the program to make a lofted shape. And before you create the shape, you can click on this preview option, and here you can see this is how the shape will be created. So once you click on apply, you have created the steel girders along the reverse S geometry. Now let us see how we can create the cross frames in the same manner. So I'm selecting the cross frames. So to select the cross frames, let us go to the top view so that we can easily select them. Here we go, selecting the cross frames. And 20 divisions again. The guide curve would remain the same. And here we go. So this is how the cross frames can be easily modeled. So basically, with the help of the sweep translate feature, you can use it to model the bridges with the reverse S curves or S curves in Midas FEA very efficiently. Now, if you are working on steel bridges which are curved, or the steel bridges where you want to study the effect of torsion, or if you want to obtain the warping stresses, you can use Midas FEA for that. Here in this particular example, I've shown you how the cross-section distorts for after you perform response spectrum analysis. Let me open this particular model in front of you and let me show you how you can obtain results for steel bridges in Midas FEA. Okay, here we go. So on your screen now is a steel bridge that I have modeled here, and I've performed the analysis. In this particular model, response spectrum analysis has been performed. And again, if you want to see how the cross section distorts, you can obtain the clipping plane, or you can obtain the slice plane. And let me show you how it looks like. So basically, you can move around at different locations and you can see how the cross section distorts. So here it looks like this. Again, you can use the local direction force sum and you can create the plane where you want to obtain the bending moments or shear forces, etc. And Midas FEA will automatically take the summation of these individual shell elements that they have. It will apply the appropriate lever arm and it will give you the results in the format that you require to create or to obtain the moment of resistance, shear resistance, etc. Okay, moving ahead, Midas FEA can also be used to perform analysis on connection of steel bridges. So here you can see that Midas FEA can be used to perform analysis on gusset plates. You can perform the stress analysis as well as fatigue analysis on these connections. Let me talk about fatigue analysis later when I'll talk about special analysis. You can use Midas FEA to perform buckling analysis. You can obtain global or local buckling in Midas FEA, and in this particular example I've shown you how buckling shape is obtained for this particular bridge type. And Midas FEA can also be used to perform construction stage analysis. So if you are constructing the bridge in separate stress stages, if you want to take into account the stress history of the bridge, you can perform construction stage analysis to obtain the stress history. And the defined construction stage dialog box in Midas FEA is same as that of Midas Civil, but we have made it even more wiser this time. We have put in the elements, the reinforcement, the boundary, the load, the contact elements, everything under the same dialog box so that you can easily see what all is activated in a particular stage. So here you can see the activated data appears here, the deactivated data, or the loads can be activated or deactivated. When you perform the construction stage analysis in Midas FEA, you obtain the results for individual stages. You can also define the time-dependent properties for steel or concrete. Sorry, the time-dependent properties for concrete. And here you can see that I have defined the creep and shrinkage properties for concrete. You have different codes which we have provided as a built-in feature in Midas FEA. We have CBFIP code, ACI, PCA, combined ACI and PCA, and ASHTO, by which you can automatically define the creep and shrinkage parameters of concrete. And if you want to define your own parameters, you can go ahead and define the user-defined parameters for creep and shrinkage. And once you define these parameters, you can obtain different results for creep and shrinkage, as I've shown you here. You can use Midas FEA to perform eigenvalue analysis. You can also use it for linear buckling analysis, as I have already shown you one of the projects. You can use Midas FEA to perform fatigue analysis. On your screen now, you can see the methods and the parameters that you would require for performing fatigue analysis. We have the stress life method and the strain life method that you can punch in to perform the fatigue analysis, and you can obtain the these results in this particular format. Now let me take you to Midas FEA itself and let me show you the fatigue analysis for a truss joint in Midas FEA. So this is a truss joint that I have modeled, and let us see how you can perform fatigue analysis in Midas FEA. So when I go to post, I have the option to perform fatigue analysis, and here you can define the property. Here I have defined the steel property, the endurance limit, and the tensile limit. Then you can define how the loads vary. So I have defined how when the vehicle is moving onto the bridge, how the deformations are obtained on this particular connection element, and the self weight will be a constant load that will be applied. And once you define all these parameters, you can hit on run, and Midas FEA will perform finite element analysis for fatigue, and it will give you the desired results. Okay, here we go. The analysis is complete for fatigue, and here you can obtain the damage. So these are three methods by which you obtain these results: the Goodman, the Gerber method, etc. Once again, let us see the parameters for fatigue analysis. I think I missed something here. Okay, so when you define the fatigue property, you can define the SN curve, and based on the code that you are working with, you can define this SN curve here, and you can perform the fatigue analysis in Midas FEA. You can model the cracked material in Midas FEA, and we have the total strain check model available in Midas FEA that can be used to study the crack propagation in an element. And here is how you can obtain the results for cracking. You can also perform reinforcement interface analysis in Midas FEA. You can define the interface material for the reinforcement, and you can see how what is the slip, or what is the friction, and how they are interacting. You can obtain that from Midas FEA. You can also use Midas FEA to perform interface nonlinear analysis. As I mentioned earlier, we have different interface models, as you can see here, and modeling the interfaces are pretty simple in Midas FEA. So basically all you gotta do is model the solid, and Midas FEA will automatically extract the outer shell for you, where you can define the interface parameter. So this is how I've created the interface parameters there. You can use Midas FEA to perform geometric nonlinear analysis. We have different methods to perform these analyses. And now let us talk about how we have integrated Midas FEA with Midas Civil. So as I mentioned earlier, that you can use Midas FEA as a complementary software to Midas Civil, so that you can be more confident of your design. And now let us see how we have integrated Midas FEA with Midas Civil. So once you create a model in Midas Civil, if you want to analyze in Midas FEA, you don't have to create the model again in Midas FEA. All you gotta do is export the model from Midas FEA, from Midas Civil to Midas FEA, and this way you can model the solid elements, the plate elements, or the beam elements. You can export the tendon profile from Civil to FEA, and if you want to export only a specific part of the model, then it can also be exported. So let's say I'm working on this suspension bridge here, and let's say I want to analyze the cable connection between the deck and the cable, the hanger cable here in Midas FEA. So I can just export this part of the model to Midas FEA, then I can do the modeling of the connection element appropriately in Midas FEA and perform the analysis to study the behavior of the connection element. Here you can also export the plate. I've shown the export of the plate and the solid models here. This is how it looks like. The model in Midas Civil, the plate model in Midas FEA, the model in Midas Civil, the plate model in Midas FEA. And you can also export the pre-stressed concrete bridges, and I've shown you an example here. So basically it's pretty easy to do these kind of exports from Midas Civil to Midas FEA. That will save you time. So you just have to model your structure once, and you can perform the spine beam analysis, the grill edge analysis in Midas Civil, or if you want to perform the 3D finite element analysis, the detailed analysis, you can use Midas FEA by using the same model. So you don't have to model things twice, and hence Midas FEA can be used as a complementary software to Midas Civil. Okay, so that is all I wanted to talk about today, and I hope I could show you how you can integrate your work that you do with Midas Civil with Midas FEA, and I wish that you guys evaluate this particular software, and you must have received an email from Jason in which he would have given you the links to several web pages in which we have talked about Midas FEA. So on your screen now is one of the web pages. I'm sharing with you one of the web pages, and I'm going to talk about how you can use the evaluation license of Midas FEA. So here you can see this is the web page of Midas FEA that we have created, and you must have got this link, the link to this web page in the invitation letter that you have received for this particular webinar. And when you go to the 4th tab here, the evaluation process, you can click on this tab, and we have listed out the several steps that you need to follow to start the evaluation license of Midas FEA. So step 1 would be to download the Midas FEA trial license, and here you can click here to download it. Once you click it, it will take you to the website, and you can download it from there. Now once you click on more information here, here you can see that the different steps for the installation are mentioned. Then you need to register in our website. You can create an ID and password, and if you already have an ID and password, you can use that. And this is how you will put it here. We have provided the production key here itself. You can put this production key into Midas FEA, and we have shown the steps here, and then you are good to go to evaluate Midas Civil in your projects. So now